Today's topic is Introduction to Equipment for Size Reduction and Principles of Size Reduction. Size refers to physical measurement or dimension of a thing or an entity. And size reduction says about decreasing the size. The larger particles or biggest particles will be reduced into smallest particles, that is especially size reduction. The advantages of size reduction: after the size reduction, when the feed is given, that is in the form of bigger particles, the size will be reduced into smaller dimensions. When we do the size reduction, the flow is uniform. The product flow is uniform. We expect the flow should be uniform, and easy and effective drying can be taking place after size reduction. Viscosity and surface area enhancement will be seen after the size reduction. Surface area increasing surface area is an important parameter in pharmaceutical food and any industries, any chemical industries, because that will increase the reaction rate. Drying and mixing will be uniform. Drying is easy of drying. A bulk amount of solids can be dried easily, and mixing further process to if they act as whatever product is coming from the size reduction, if it is acting as any reactant, that particular mixing is very much uniform, and rate of absorption is also increases. Dissolution rate also increases, especially when we talk about tablets and all. The dissolution rate increases. It has to be diluted when it is entered into body. And the disadvantages, because if the surface area is increasing, it may react with anything. It may be non-reactive sometimes. Because the reaction, whatever we are giving options that you can react very easily. So if it is not reacting with target, so then it will be a problem, because whatever tablet we are taking to cure the problem, so then the degradation and surface area, if it is more, the degradation will be more and may leads to contamination, and maybe non-reactive. Sometimes it is reacting with any other thing also, maybe non-reactive to target. Now, size reduction equipment. Basically, there are four types of crushing equipment. Comminution equipment. One is crushers. This is a crusher is a primary. It will be used for the bigger, larger particles. Next is grinders. Whatever is coming from the crushers can be used for the as a feed for the grinders, and it will be further size reduction will be taking place in grinders. And then ultrafine grinders, and then cutting machines. The size reduction equipment is divided based on the size of the feed or size of the product requirement. Crushers are basically divided into primary crushers and secondary crushers. Primary crushers operates between 150 to 250 mm feed, and the product can be 250 mm or 150 mm or nearby that. Whereas secondary crushers, the product size will be 6 mm. If it is less than 6 mm, it will be next, grinders, it will be grinders. So the crushers are divided into primary crushers and secondary crushers. Primary crushers operates on runoff material, accepting anything comes from mines directly. Whatever it is coming as a crude product, that will be taken into as a feed and can be given to crushers. Whereas secondary crushers, whatever is coming from the primary crushers can be given into secondary crushers. And then secondary crushers to grinders. And primary crushers generally follow the principle of compression. Compression. What is compression? Compression means where two joints or two jaws will be given and the material will be fed in between. Because of pressure created on the two joints or two things, the compression will be created, so the material will be broken into smaller pieces. That is the basic principle of compression. And then compression is the main principle generally happens in crushers. Then when we talk about next after crushers, next one is grinders. Grinders are divided into three types. intermediate grinder, fine grinder, ultrafine grinders. But intermediate grinders also, whatever product is coming that has to pass through 40 screen, then we will say they are intermediate grinders. Whereas fine grinders, whatever material bit is grinded, it has to be passed through 74 screen, then it is called fine grinders. Next one is ultrafine grinders. It accepts feed particles no larger than 6 or 1/4 inches, and the product size is 1 to 50 average size. Okay, so in grinders, the product average size is 1 to 50 micrometer average size. It can be a bit larger or lesser. Maybe it can be some size, mixed size, maybe with along with crushers or later ultrafine grinders, because the equipment is divided into crushers, grinders, ultra fine grinders, and cutters. So this is ultra fine grinders. And grinders and ultrafine grinders, if we talk about, grinders employ impact and attrition. We understood what is compression. Compression means we take the action of being compressing or being compressed by two things. Okay, two jaws is called compression. Here crushers will be acting based on the compression, whereas grinders will be acting based on the impact and attrition. What is impact and what is attrition, I'll be telling you later. And they may take, if needed, sometimes compression also they will take. Ultrafine grinders operate principally by attrition. What is attrition? I'll be telling you. Next, fourth one is cutters. Gives particles of definite size and shape, because whatever we want, a desired shapes can be cutted. That is with cutters. 2 to 10 length. And cutting action is of course characteristics of cutters, dicers and slitters. And 2 to 10 length. Size is very important. Particles can be cracked into two rigid forces. Now I will tell you, there are four principles we were talking about: compression, attrition, impact, cutting. So what is compression? I already told you there are two rigid surfaces will be given. The two rigid surfaces and the feed will be given from the top. When the feed will be given, because of these two rigid surfaces, compressing or pressure will be created, and when we compress these two rigid surfaces, the particle will be broken into small particles and they will be crushed into small particles, and but work will be done by both the surfaces. This is the basic principle of compression. Compression, the action of being compressing or being compressed, the reduction in volume causing an increase in pressure of the mixture. This is compression. And when we need a compression, if hard materials are there, abrasive materials, dry materials, not sticky materials, product size is coarse. Products are coarse size. And example you can see here, nut cracker. Nut cracker is the example of compression. Coarse reduction of hard solids to coarse sizes. Coarse, medium, fine. I think you remember coarse, medium, fine size particle. Nut cracker is the example of compression. Next one is impact. The impact here is single rigid force. Particles can be cracked into a single rigid force. Whereas in compression, particles are compressed by using two rigid forces. Whereas in impact, particles can be cracked into a single rigid force. And we get the feed will be brittle, hard, abrasive and high moisture. And we give the products of coarse, intermediate and medium size or fine size particle. This is example of impact. Impact example is hammer, Hammer, hammer. Next one is attrition or rubbing. Particles rubbing or grating, touching one another against a rigid surface is called, like, it is not that both the sides we are applying the pressure. It may be the moving this side, so rubbing is created and then the attrition is happening, so the particle size will be reduced. Example, feed is soft abrasive and the product may be fine particle. The example is file, FILE. What we'll do with file? We will try to rub it or attrition we will do and then we get the fine products. This is how the attrition, example of attrition equipment, that is file, FILE. Now when you see the actual principle of abrasion, compression and impact, abrasion or attrition, when you see that, we will try to rub it by using file and then we will be reducing the particles. Like whatever is there on the upper side, if you see the cursor, see whatever is there on the top, that is abraded or grated by using attrition. So we get abraded, this powder we got, and also this particle is size is reduced, but this powder can be used or whatever this particle is used. Whereas compression, this feed is given to between two rigid surfaces and then the pressure is applied between two rigid surfaces and then particles will be broken into smaller particles and then compression will be created. Here the impact means only one side, one rigid surface force will be given, and like by using hammer we will try to put it, we'll try to stick it or we'll try to put it on that. Then the impact, because of impact, the particles will be reduced, size will be reduced, and then smaller particles will be getting. And impact, more energy is required, whereas abrasion, the less energy required. Compression, medium energy is required. And if you talk about the overall comparison of compression, impact, attrition in cutters, compression is coarse part. Compression generally applies for the coarse reduction to coarse size. Okay, coarse reduction means larger than coarse particles. So coarse will be the feed and coarse will be the product. Example is neck crackers and we will be giving positive pressure. Whereas impact talk about gives coarse, medium to finer products. If we are giving coarse or medium size feed, we will be getting fine products. That will be the example of hammer, and material is stationary and hit by an object. This is the impact working principle. Attrition is yields of fine products and breaking the edges of the solids by either by impact or particle collisions. Cutters gives a definite sizes, sometimes definite shape. Example is cutting force. Thank you.